that we decided to try out as a alternative to writing dashboards in Shiny. And we are going to go through the basics. I'm going to show you a demo of what an app built in Dash looks like. And then I'm going to show you the lessons that we learned while building a project in the Dash technology. So what is Dash? Basically, Dash is a Python framework that lets you build web applications. It is fully maintained and created by Plotly, and it is fully open source. So whenever you are in doubt of how things work, you can visit GitHub and see Dash implementation to see how things are built. It uses Flask. It is built on top of Plotly.js and React.js. And the way you build the dashboard is in pure Python. So you are not touching any HTML code, at least while you are using Dash and additional components. If you want to build additional components, you will have to also use React to build customized components that you want to use. It is released under the MIT license, so it is free to use in all of the projects. So what do we get with Dash? Basically, you get full frontend, which is generated in Python. There is a reactive computations abstraction. So you have a reactive graph that gets recalculated just exactly as it is calculated in Shiny. For every HTML tag, we have ready Python classes that we can use to create any HTML element. And there are some interactive HTML elements that are implemented in Dash core components that you can use. What's more, there is a special component which is called graph, and it allows using any Plotly graph that is available from the Python API. So this is a very good gain when you want to create nice looking visualizations in your dashboard. You know that you have everything that you get in Plotly. You can use it in the Dash application. So let me quickly show you what a demo of the Dash looks like. Maybe first let me show you the source code. So here's an app that I created. It first defines that app is going to be created from Dash, and you create layout using HTML tags like div, h1, or input element. Let me make it bigger for you. I'm going to go through this in a little bit more detail in a moment. I just wanted first to give you an overview of what the Dash application looks like. So you create different elements, and then you define callbacks, which basically tell you that whenever an input changes in the HTML structure above, there is going to be a change in output. So in this example, you have text input, which is here as HTML ID. And any change in this text input is going to be shown in the text output. So here is the text output. And you define the method that is going to be run whenever the input changes. In this example, we are just returning information that you have entered, and here is the input value taken from the input. So let's run this code. And here it is, our first Dash application. We can see the inputs. Whenever we type anything, it is updating the value in the text output. And we also see a nice looking graph, which was created using Python API. So we are going to go back to the code in a moment. Let me first give you an overview of what are we doing in order to create such a dashboard. So first, the full layout gets composed with the components that you've seen, and we can use the basic HTML components provided by Plotly So for example, a div, h1, or the dash core components, which are interactive. And in this example, we use the graph component. As I said before, you get every tag for every HTML tag. You can use it in Python. And any component that needs a little bit of JavaScript, a little bit of interactivity, is not implemented in the main HTML library, but is implemented in the dash core components. I'm going to show you what kind of components we can use, which are ready to use, and if they are not there, we have to implement them ourselves. So every component is described with the keyword attributes, and you can hook up to any of the attributes in order to create reactivity or any interaction. From the special properties, there is a children property, which basically it is the first attribute, so you can omit it. I would advise always writing it because it is more explicit. You can see what's going on there. And children basically tells you what is the inside of the HTML tag that you are using. Another thing that differs from the HTML is that the class is replaced with class name, and basically the style attribute can be a dictionary. So if you want to inline a style, you can just create a dictionary. And just remember that whenever there is a dash that you need to write, so for example, when you write margin left, instead of writing the dash, you have to uppercase the next letter and remove the dash. So as you see in the example, there is, instead of margin left with a dash, you just write margin left. What's also important is that all the attribute values must be serialized to JSON. So there is no way of trying to push some objects that are not serializable. So you need to keep that in mind when you are creating the app. So how do we get interactivity? As you've seen, we are creating inputs and outputs, and these are used in the app callback decorator that you have to use in every method that you write. Basically, each input and each output is the attribute that I mentioned in the previous slide. So you can hook up to any attribute that is defined in Dash. So it doesn't have to be only one input that makes recalculation. As you see in this example, you can create a callback that is going to put the results to the output for the indicator graphic figure. And there are many inputs that you can write, and whenever any of those inputs changes, the output is going to be recalculated. So you can just imagine that there is the graph that whenever a node changes and node is an input, then there is going to be outputs recalculated. So the important thing, this is one of the first drawbacks that we get in this technology, is that each dash callback function can only update a single output property. So whenever you want to update, for example, two outputs based on the same inputs and the same calculations, you have to start using intermediate values. And the problem is that there are no intermediate values. So basically, if you want to create a computation that is common for a few different inputs and few different outputs, you have to use a hack which is suggested by Plotly. And there are two different hacks that we can have. So first one creates a hidden div where you basically output all the calculations of that you make. And the other one is to use an external store to keep the values, which is a little bit over-engineering in my opinion. But maybe in future we will get intermediate values from Plotly. I can't wait to see that. There is also another one, apart from the output and input, there is also a state, which basically is the same as input, but whenever state changes, it is not going to trigger a change in the reactive graph. So you can just think of it as supporting additional variable that does not trigger the change. So how does it work? Well, you declare the app layout. It is the static code. You just create the basic structure of your application. You define the callbacks and you run it in the browser. Basically, what we do is we change the state of the HTML nodes in the browser, and whenever state changes, it's going to ping the backend that something changed, and it's going to get the result in return. And this is fully written by Plotly, so we don't see it. The important thing to know is that this is done via the HTTP requests. So whenever an input changes, you are going to send an HTTP request to the backend, get the results, and update the DOM in the browser. Backend basically recalculates the graph of dependencies and sends back the list what changed in frontend. So let us take a look at the code. I'm going to show you, now that you know exactly what is what it looks like in practice. So we have the Dash application. We create a list of elements. There is h1, which just says hello Dash. There is a div. There is an input that allows you to enter a value, and there is an output. And apart from that, this is the graph component, and figure defines the figure that you want to see from Plotly. You can make, for example, this an attribute and change the figure based on some other input. So if you want to recalculate the graph when someone, for example, increases the amount of samples that he wants to show, then you just, instead in output, you would write example graph figure here in output, and then you would return this part, which would be changed based on the input that you wrote. So just to show you an example, let's say that we have this input and we would like to output the calculations to two different divs. So as I said, you cannot have two outputs. Instead, we would have to either have the same calculation done twice, or we would have to add an intermediate value. So just for example, I'm going to show you what it looks like if we wanted to do it with two computations. So we'd have like text outputs 2, where we would like to output the same thing basically. And you would basically copy this code. And here it is. So now we have two outputs. We can change the input, and it's going to update each of the outputs. But the problem is that we have a repeated code, as you see, because we are calculating this sum of two strings twice. So if we wanted to do it only once, because let's say this is a very long-lasting computation and you don't want to do it twice, you have to create an intermediate value. So we would write like a hidden div. And this is what I said. Instead of just writing the style as you would do in the HTML components, you create a dictionary, and then we are going to say display none. So now we have a hidden div, and instead of changing the output of text2 ID, maybe let's copy that. We are going to set the outputs to hidden div. And now for the other two, we are going to change the input to hidden div, and same goes here. And instead, we are going to just return the calculated value, which is going to be you have entered something. Okay, let's see if everything looks good. Yep. Oh, we are not listening to the value right now. This should be children. Oh, sorry. Here this is children because we are writing to basically the inside of the div. So taking the value from the input, writing it to the children of hidden div, and whenever children of hidden div are changing, we are changing both text output 1 and text output 2. All right, so there we have it. So basically, this is what you have to do, the limitation that you have to overcome when you want to do some calculations and have intermediate values, creating a hidden div. This is quite important because in bigger apps, it is going to be used a little bit more often. And it is important when you want to build an app in Dash to design those intermediate values wisely to avoid having issues later in the code. So let's go back to the presentation. For the Dash core components, I listed them for you so that you have an overall idea what additionally we get. If you want to just build an application, you will get a drop down, you will get a slider, range slider, input, text area, checkboxes, radio items, button, date picker, single, and the range. A markdown, which is actually quite a cool component that allows you to render markdown and display it in HTML. There is an upload component, tabs, and graph, which I showed you that allows you to use Plotly libraries. There is also a new component which is called interactive table, but this is under development, so we can play with it if you have time and this is interesting to you. Then just go ahead, download this repo and play with it. Probably in future it's going to be just added to Dash core components. And during the project that we were working on, we had to create our own Dash components library. We call this Dash semantic because we decided to use semantic UI with our dashboard. And we started adding components that we decided we needed in the app. So there is a link for you if you were interested in how to actually create your own components. It may be useful for you if you decide to implement more features to our current code base of Dash semantic. For now, what we have and what you can use is a leaflet map that allows you adding, for example, raster images to the map or allows you adding multiple layers. There is also a timeline component, which is very useful, allows you to choose given dates from a timeline. There is also a mix panel hook, which is actually a small component, but allows you to add a mix panel to track what users are doing. And a small include script component that basically, there is a small problem with Dash when you want to include a script, and this allows you to do it easily, basically. So basically, what I just wanted to add is that our Dash semantic is not open source yet. This is our internal library that we use in our projects. Probably I'm going to create a separate tech talk also to introduce you to the library, to show you what we have here and what cool stuff we can build with it. All right, so there is one more thing that I wanted to show you is the fact that how Dash basically works when it comes to blocking computations. And if you wanted to, let me just show you the code that I have prepared for you. Let's say that we have an application very similar to the one that you've seen. So we have basically I created 2 inputs instead of 1. And they are going to show what you wrote. But before actually outputting the value, we are going to sleep 5 seconds. So we are assuming that there is like heavy computation going on in the backend, and then we are showing the result. So let me show you what it looks like. First, when I run the app, as you can see, there is an updating information, which means that Dash is basically recalculating the values. and now it finished. Let me show you what happens when I change just one value. It's going to say updating, wait 5 seconds, and then it's going to show the result. But what is interesting is that, same goes for the second input. What is interesting is that these two are completely independent calculations in the graph, so that they don't have a common piece. The first one depends on the first input, the second one depends on the second input. So we could assume that they would be calculated like fully independently. However, this is not the case. So if I write 2 and 2, then we would have to wait until both of the computations are done. So it's going to happen very, very long. So as you see, first you had to wait 5 seconds for the first one, and then only then the second computation started. So it took 10 seconds in total to actually update the two components. So as you know, this is not ideal. What is also not perfect is assuming that we have two applications running for two different, completely separate sessions. This is something that we should be aware of. I'm going to show you how to fix that, but the important bit is that, let's say I'm changing a value here and then here, and someone refreshes this page. As you can see, this does not get refreshed until those computations in the second window are finished. So the same goes if I go create a new page, then this is going to just hang until both of them are finished. So there is a lot of blocking that goes along with the app, even though we are talking about completely two different sessions, which is far from ideal. And there is something we can do to make it better, though. So we can extract the Flask server that is provided by Dash and use the GUnicorn solution that allows you to basically have multiple processes using this server to serve the queries. And this allows you to basically preforks it preforks the server and just sends over the requests. So this is very useful, and I'm going to show you how it works, especially that it is going to improve, and this is different from Shiny, this is going to improve also the usage of the UX of a single user. So let me show you what it looks like when we run GUnicorn. You specify how many workers you want to have and how many threads. Oh, now this is running on 8000 port. And here it is. You're going to see that it's going to pop two results at the same time. It is not waiting for the first one and then calculating the other one. And the same goes for the values for one single user. So as you see, the second one pops out exactly after the first one, which is great. However, what is not perfect is that, let me just show you that this also works for the two different browsers. So whenever we update this one and this one and this one, then we just wait and all of them are updating independently. Although this one is slow, let's do it. Let's try it again. All right, so as you can see, all of them updated almost immediately after 5 seconds. So there is a better level of concurrency that we get. What is not good though is that when you think about how it gets calculated, let's say that I'm changing the input 5 times, then there is not one callback that is called, but it's called there are 4 callbacks that are called, but the result of the last one is shown. So we can very quickly block the concurrency if we input a lot of values, and this is going to just wait in a much longer time because there is not enough threads. So it's not highly concurrent. We are going to change it, but then we have to wait, for example, for this result a little bit longer. It does not get updated immediately. And this goes as well for the multiple applications. So at some point, if we create many of them and they keep updating, after a while, you just cannot get a new application. You have to wait for them to update. And this one is going to load until all of the other ones stop, finish loading. So it is a huge problem if we want to build big apps that do complex computations. But at the same time, this just means that we have to change the architecture of the application that we are building in order to avoid having long computations in the dependency graph, and just add additional processes, for example, that we are going to offload the difficult job to like externally and wait for the process to finish, but not block the dependency graph. So this is a very important thing to keep in mind when building the apps. Right, we're slowly getting to the end. I showed you the threading, and let me just sum up the limitations that we have. So we are not sure yet how it's going to scale for many concurrent users. We've seen that during the examples or checking the running the performance test, it is not behaving in a perfect way. At some point, we are going to need more complex components, so we are not going to avoid writing our own components in React and HTML, which is not bad. I mean, this is a lot of fun, and we can create actually a great set of interesting components for our use. And what we can also do is to leverage the libraries that are already there, which are written in React. And there is a little amount of work that you have to do in order to port a library from React to Dash. So you will quickly find out that a lot of, maybe not a lot of, but some of the easy components are still under development. I think that Mapbox is a good example. We wanted to use it first, but then realized that we cannot add a single picture to the map because the raster is not implemented yet, and that's why we had to implement our own leaflet port. All right, so I'm wrapping up. No intermediate values that I told you about, separate output functions, and basically there may be some issues that at some point we will have to learn how Dash works by heart in order to find out what is flying there. And there may be things that we may not know about yet about Dash. So this is still an experimental project for us to learn, to see where it goes. I think it's a very useful project, very nice when you work with it, and you can build dashboards very quickly. So I encourage you to play with it, to try to see how it works. And of course, I'm very open to any discussions. If you have any questions, just ping me. All right, so that's all.
So I can start with questions. So one thing I was wondering about is, do we have, does Dash keep any state on the server, or like for example Shiny does, or is all the state kept on the client?
Can you repeat the question? I didn't get you.
So for example, Shiny, for each session, it keeps the state on the server. So it has all the values that are displayed on the client, also on the server. So when one value changes, the new value is transmitted to the server, and then the computation is ran on the server. So the question is, does Dash keep the state on the server for each session as well, or does it only keep the values on the client.
So the good thing about Dash is the fact that it leverages React.js, which basically makes it keep the whole state in the app, in the browser. However, of course, you can keep some of the values in your application, but from my experience, it would be much easier to actually have like a key store, a key value store like Redis hooked up to store intermediate values or the session values that you have instead of writing them in the app. So there is a big plus for Dash in that part, in that field.
Yeah, I can see advantages of that, but also disadvantages, like if you have a lot of data in the input and output, then for each change you need to transmit all of them to the server.
Exactly. When it comes to much bigger values, then it is much better to implement a separate key value store to handle such operations. I mean, the intermediate value workaround that was provided by Plotly is good, but probably not best when it comes to much complex solutions. And then we have to add more time of hours to basically implement the solution in a much complex way. But at the same time, it's going to give you good returns then.
How about using memoize functions? Like that probably is a good idea to solve just like maybe half or more of the issues we might have with intermediate computations.
Yeah, that would help. I think this is worth noting that using memoize would be a good solution. Although it's, as Mark said, this is going to depend on the amount of data that you store, because
if you like have 12 workers with 4 threads, then each thread, or at least each worker, will have a separate memory. So unless we implement like
multi-threaded memory.
Yeah, exactly, because there will be a high chance of missing the cache, basically. That's true. But it all depends on the app that you're building, right? All right, so any other questions?
So when would you recommend to use Dash instead of Shiny? Because as I see it, Shiny has this advantage that it's much more mature.
Mm-hmm. I think that when building more complex solutions, it could be actually useful to leverage the fact that we can build our own components in React, because this allows you to build much more. But at the same time, Shiny is very good when it comes to prototyping. I would have to work more with Dash to actually make sure that I can recommend it as a solution for huge projects used by many concurrent users. But for now, I would say that using Shiny is okay for building the applications, for first prototyping. Dash is good as well. I would recommend using Dash when you have more complex components to build.
Yeah, I wanted to cover the topic about multiple concurrent users, because it seems like in Dash we have the very same solution as we have in Shiny. So when we want to scale, we just have to use Shiny proxy or Revolver. I think this is the only solution for Dash. Is that correct?
Yep. For now, this is the only solution.
I have one more question. Like in general, we can all see that the API, or like the way you write reactive computations, is different than in Shiny. So because you need to explicitly give the list of inputs that you will be observing and the output. And I can imagine problems with that, like that you, for example, forget to include some input, perhaps, or more likely that you write 2 functions that write to the same output, because you can do that, and in Shiny you could not.
No, you cannot write to the same output from two different callbacks. This is going to throw an error.
Well, okay, I see. Okay, so in Shiny the dependencies are calculated automatically. So the question is, like, what is your general feel about how do you feel about this different model of writing applications? Is it more problematic, or is it more efficient and pleasant to use compared to Shiny?
I wouldn't say that this is actually a complex thing to do, because basically it is not problematic in a way that there is a compiler that tells you that you cannot write to the same outputs twice. It is going to tell you if you have problem with the function declaration. So, for example, you say that you have this argument, but you don't write any input to that. And also, you cannot use an input that you didn't declare. So this is something that is going to be quickly shown to you if you have such errors. I think that the biggest problem is that building Shiny apps, we can define quite complex reactive variables, which are intermediate in the graph. Whenever writing Dash application, there is no intermediate values. So this is the biggest limitation that I would say, and the most problematic one so far. Cool. Any other questions? Okay. Thanks, guys.
Thanks.
Damian.